Now again, we repeat, this isn't in real good form, especially this square root of 16/3 down here. We'd write that as 4 square root of 3 over 3. But this is the ellipse that we got. We did have an error there. The 48 should have been a 56. So these numbers aren't really accurate for the ellipse that we started with. But the procedure is correct as indicated. Now, if we did end up with this ellipse, let's see how we would graph it. Okay, the square root of 12 is approximately 3.5. The square root of 16/3 is approximately 2.3. The center of the ellipse is at x equals 2 and y equals -1. So, centering the ellipse at 2, -1, if here's our y-axis and our x-axis, we come over 2 and down 1. Here's our 2, -1. The scales in the x and y axes are not particularly accurate here. They're not particularly consistent. The x scale is much bigger than the y scale, and it would have been more appropriate to have the same scale here. But in the interest of distance or something, I guess we compress the scale on the y-axis. In any case, center at 2, 1, 2, -1. So we come out 2, down 1. We sketch the rectangle. We come out another 3.5 units here for A, which is our 3.5 roughly. And we come up approximately 2.3 units for B. We draw this rectangle, then we draw the ellipse within the rectangle. And had we done everything right, this ellipse would be identical to the ellipse defined by this equation, because this equation would have been simplified to this form. Again, the 48 instead of the 56 means that this is a little bit off. The foci of the ellipse, well, a squared equals b squared plus c squared means c is the square root of a squared minus b squared, which will be the square root of 12 minus 16/3. And that comes out as it does. 12 minus 16/3, I guess, is about 6 2/3. Square root of 6 2/3, so it'd be about 0.26 or so, or 2.6 or something like that. So if A is 3.5, the focus would be at 2.6, maybe about there. And the focus on the other side would be symmetric with it, about the center of the ellipse.